numbers, right? And page 13, question 11. Page 13, question 11, right? If x plus y squared, x plus iy squared equals 8 minus 6i, find x and y, right? Okay, there's a couple of ways you can do it. You can raise it to the power of a half, right? Or you can just square out this side. So square the first, twice the first by the second, 2xyi, plus square the last, which would be y squared, I squared, equals 8 minus 6i. Replace that I squared with a minus 1, so that would be x squared plus 2xyi, and that would be y squared by minus 1, which would be minus y squared, equals 8 minus 6i. And then it's a case of pick the real bits on the left equal to the real bits on the right. So the real bits have no i's in them, so it's x squared minus y squared equals 8. Can't do anything with that. The other one is 2xyi equals minus 6. Sorry. Yeah, I'm just checking. Minus 6i. I was just checking the real. Yeah. So you get 2xy equals minus 6. You'll get xy is equal to minus 3 divided across by 2. And then replace it with x is equal to minus 3 over y. Or you could go the other way. Y equals minus 3 over x. Back over here, everywhere I see an x, I'm putting in a minus 3 over y. So that to be squared minus y squared equals 8. So that would be 9 over y squared minus y squared equals 8. Get a common denominator. So common denominator is y squared. So y squared into y squared goes once, so it's 1 by 9. Y squared into y squared goes y squared times, so it's y squared by y squared equals 1 into that goes y squared times 8. Sorry, I know that got a bit squashed there, apologies. Right, okay, drop your common denominator, you've evened up everything, so I have 9 minus y to the power of 4 equals 8y squared. So we can rearrange that, and it's y to the power of 4 plus 8y squared minus 9 equals 0. Right, okay. So instead of having y squared here, we have two sets of brackets. You can use y squared and y squared. 9 and 1, a plus and a minus. So you'll get y squared is equal to minus 9. That's not an answer because you can't get the square root of minus 9. It doesn't exist. And it said x and y are real. I know we're in complex numbers, but it says in the question that x and y are real. That's not an answer. That's not a real number, right? And then you get y squared equals 1. So that means y is equal to, it can be a plus 1 or it can be a minus 1. Is that alright? Then back to x is equal to minus 3 over y. So x is equal to, so when y is 1, x is equal to minus 3 over 1. So that means x is equal to minus 3. That's one answer. And when y is minus 1, x is equal to minus 3 over minus 1, which means x is equal to plus 3. So there's the second answer. So that's one set of values, and here's the other set of values. Is that right? Any more questions on complex numbers for me? You're all 100% in the test tomorrow. Great. You sure? Going, gone? Right, okay. Um,
Actually, I don't know if we did this yesterday. That's why I'm hesitant to ask.
go on, ask it again.
You know,
Sure, if I
like
did it yesterday, I can do it again.
Worksheet. The last question on it.
What's the last question on the worksheet?
I'm not sure.
On the exam questions I gave you. Yeah. Hang on a sec. I'll have to get it up here. Okay. Complex numbers. Where am I?
Excuse me, please, Miss Nancy Reedy, second year, Patrick 2, resource French class. Did they come to reception now?
Let's see. I can't find it. Sorry. There it is. So the last question on the paper is.
Excuse me, please, if Ella Keck come to reception now?
B part 1 is it? Let Z modulus or Z conjugate. So W equals Z1 times Z1 conjugate. Did I get Z1? Yeah, I got Z1 in the first one. Did you get part A done?
1 minus 2.
It's 1 minus.
Wait, so the answer of part A?
Yeah, is the answer. You use that in part B.
Oh, I think it's 18 plus minus.
Say that again. You got the root in the other one.
Yeah, I'm not sure.
Find the other two roots. Oh, it tells you Z1 up at the very top of the question. Sorry, apologies. If I looked at the top of the question, I would see that Z1 is equal to that. Okay? Right. So to get W then, B part, is it the A part, the B part, or the C part, or the whole lot?
It's the B part.
Yeah.
I'm not too sure. Like, I didn't even look at the answers, but I know I got it wrong. So
Yeah. Can I see which bit you're looking at?
yeah.
I might know by looking at it which bit you. Yeah, B part. Oh, I'm so sorry. B part 1. Right, okay, so B part 1 says, okay, girls, it was the last question on the sheet, the exam questions I gave you. So it says Z1 is this up at the very top of the question. It said W is equal to that, right? And you have to plot Z1 conjugate and W on the Argand diagram, okay? So you plot Z1 on the Argand diagram, that's fine, that's 1 minus 2, there it is, that's Z1, right? Z1 with a line across the top of it, that's the conjugate, okay? And that's just change the sign of the imaginary bit.
Sorry, I just have to go to the student house.
Yeah, grand. So change the sign of the imaginary bit, so that's 1 plus 2i, is that okay? So plotting that on the Argand diagram, Z1 conjugate will be here. Is that okay? And then it says W is equal to Z1 multiplied by Z1 conjugate, which is 1 minus 2i multiplied by 1 plus 2i. Multiply that out, that's 1 minus 2i plus 2i minus 4i squared. They cancel, replace the I squared with a minus 1, so that becomes a plus 4, so that's just 5. Okay, so 5 is 1, 2, 3, 4, 5, so that's 5 plus 0i, there it is. Okay,
Yeah, I got that. Yeah,
you got that, the next bit, right, okay. Okay, next bit. Stupid, move, yes. Find the measure of the acute angle formed by joining Z1 to W to Z2 on the diagram above. There's the acute angle. Oh, it's this is W, so the acute angle you want here, right? Agreed? Right, okay. Just take one triangle is the mirror image of the other, right, isn't it? So just take one right angle triangle. So let's just take the top triangle. I need to find the measure of that angle, and then I'm going to double it, agreed? Right, so it's across, and that goes from 1 to 5, so that would be 4. That line measures 4, agreed? Because it goes from 1 here across to 5 here, so it measures 4. and this goes from that up to 2, so that measures 2, right? Okay, and then you use a trigonometry. So tan of x is equal to opposite over adjacent, which is 2 over 4. Then you get the inverse tan of a half and double it, and that's your answer. Is that right? Okay, so that was it. Any more questions for me on complex numbers? Anything else off that sheet? Anything, anywhere? Right. Be easy, correct your test though, because they'll all be right. Okay, great. Okay, sequences and series, so here we go. So sequences and series and patterns, you would have called them number patterns in junior cert. Okay, so the first few sections are just revision of all the stuff you did in junior cert. Okay, so I got back to the green book, right? Okay, I'm hoping to get two to three sections done today, and then we'll leave it until after Easter. Why am I starting a chapter the day before the Easter holidays? Basically, we're under pressure for time, so it's better, the more we do, the better. Okay, just in case you think I'm just being unrealistic. I'm not. We're way behind, so, well, not way behind, but we're about 3 weeks behind, so. Okay, right. Sequences and series. So it's book 4, chapter 9. So the first section is really easy. It's just basically what's a sequence. So sequences, I might use a different pen because I need a good one. These boards are so dirty. So sequences, series, patterns is the name of the chapter. So first section is on sequences. Okay, so sequences is a number pattern. So a number sequence is a set of numbers. I think I can do better. Set of numbers written in a definite order . Right. In most cases, all numbers, all terms in the sequence are connected by a rule. So all terms in the sequence are normally connected by a rule. So sometimes they give you the rule and ask you to write out the sequence. Sometimes they give you the sequence and say, what's the rule? Okay, so you have to be able to go, and you learned all that in junior cert, right? So you learned, here's the rule, give me the sequence, here's the sequence, give me the rule, right? Okay, so the rule is the first term, T1 is the first term. Do you remember this? Does it make sense? No. Or is it like a foreign language? We'll see in a minute. T1 is the first term. T2, what do we call that? The second term. So it's term number 2. And then all the way up, and we call, basically, if you don't know what number of it's term n is goes all the way up to term n, whatever term n is. Term n can be any number you want it to be, and Tn is normally, right, the rule, right? Okay, so Tn is normally the rule. Okay, is that right? Okay, so I'll jump to a few examples. Right, so we'll just practice a few of these before we examples. I'll just load them all in there together. I won't call them 1, 2 or 3. I'll just go examples. Right, okay, so if I had a sequence 0, 3, 8, 15, 24, what would the next term be? So you've to spot the pattern. So basically you add 3, you add 5, you add 7, you add 9, what will I add next? 11, so I'll go up to 35, and then I go, so I'll just write in, just so you wanted a load of numbers written in your copy, plus 5, oh, that was plus 3, plus 5, plus 7, plus 9, plus 11, and I'll just write one more term, plus 13, yeah? So that would be 48, okay? So can you spot the pattern and repeat it? Okay, yes you can. Right, next one, 3 minus 6, 3 minus 6, 12, minus 24. Write me down the next 3 terms. So I'm going 3 minus 6, right? So first off, let's look at the numbers. Let's look at the numbers. Are you doubling the numbers every time? So 3, 6, 12, 24, yeah? Okay, so you're doubling the numbers, aren't you? You're spotting the pattern. So the next one would be 48. The next one after that would be 96. And the next one after that would be 192. Agreed? Then let's look at the signs. Plus, minus, plus, minus, plus, minus, plus, etc. Okay, so there was 2 different patterns going on there. The pattern with the numbers and then the pattern with the signs. Grand, we all good? Yeah, okay. And then, so I'll just say that's 1, 2. And the last one is a half, a sixth, a 12th, a 20th.
Excuse me, please, any students who would like to purchase fashion show tickets, I have just 2 or 3 here in reception that can be bought. Thank you.
Okay, I'm having bother spotting the pattern myself here. Right, okay, at 4. Oh no, it's grand. Right, there's nothing going on up right, okay, up above the line is always the same. Yeah, is that okay? Below the line, to go from 2 to 6 you add 4, would you agree? To go from 6 to 12 you add 6. To go from 12 to 20 you add 8. What will I add now? 10. So I'll get 1 over 30. And then I'll add 12. So I'll get 1 over 42. And then I'll add 14. So I get 1 over 56. Are we good? Took a minute, but I got there. Right? Okay. That's 1. Will you get that? Hopefully you'll be asked a question like that, but we'll see. Right? Okay. So now I'm going to do examples of where I give you the rule and you give me the terms of the sequence. So, right? Okay. So, we'll say given the rule. So examples. I'll just go examples again, and I'll put in brackets. So if you go up, back up to that examples, will I just put spot the pattern? So they're all examples of where you spot the pattern. You can't see that, can you? No. Okay, spot the pattern. Is that alright? And examples, given the rule, write out the first 3 terms. So I go if Tn is equal to 2 to the power of n. So what you have to do is write out term number 1, term number 2, and term number 3, the first 3 terms. Okay, is that right? How do you get term number 1? Everywhere you see an n, put in a 1. So it's 2 to the power of 1, which would be 2. Right, term number 2 would be 2 to the power of 2, I'll answer it so, which would be 4. And the next one is 2 to the power of 3, which would be 2 by 2 by 2, which is 8. Okay. Then 2 to the power of 4 would be 16. 2 to the power of 5 would be 32, etc. Is that right? Okay, that's one example. A second example. Tn is minus 3 to the power of n. And again, the question is write out the first 3 terms. So T1, T2, and T3. So T1 is minus 3 to the power of 1, which is minus 3. T2 is minus 3 to be squared, which is 9. T3 is minus 3 to the power of 3, which is minus 27. Is that okay? And so on. T4 would be plus 81. T5 would be minus 243, etc. Are we good? Right, so this is where you're given the rule, right, and you have to tell me what the terms are, right? The whole next section is given the sequence, come up with the rule, okay? Right, so another last example, Tn equals n multiplied by, that's what the dot means, n multiplied by 2 to the power of n. Is that okay? So that just means multiply. So you write out T1, T2, and T3. So T1 is everywhere you see an n, put in a 1. So it's 1 multiplied by 2 to the power of 1, which would be 2. Next one is T2 is 2 multiplied by 2 to the power of 2, which would be 8. And the last one then is T3 is 3 multiplied by 2 to the power of 3, which is 24. Is that okay? We good with that? And that's the whole first section done. Okay, there's a thing spotting patterns as well. So what I'm going to do is I'm going to give you a few of these to do, and then I'm going to move on to the next section. So I'm going to can I take this away? Right, okay, will you do all the middle column here? Is it okay if I don't put up a photo? Can you read it here if I put the camera on it? Are you able to read that? All this. So do all these, all the middle columns. So spot the pattern, write in these 5, and then write me out the first 3 terms in these 3. Okay? And